Now we will prove that 2 implies 3. That is, if L is a separable algebraic extension of K, and then F is a Galois extension of L, whose Galois group over L is isomorphic to Z mod PZ, then we have the following. If the P primary torsion part of the Brauer group of L is trivial, then the norm map must be surjective, the norm map of F over L. That is, every element in L must be a norm. The key idea here is to use the cohomological description of this relative Brauer group. And now in this case, because the Galois group is cyclic, we know how to compute cohomology of cyclic group. In this case, it should be the quotient of the fixed field of the Galois group over the image of the norm map. So that's just going to be L star quotient out by the image of the norm map. Now because the Galois group is isomorphic to Z mod PZ, the elements of the Brauer group being identified with cocycles on Z mod PZ star, these must be killed by P. Right? So this must be killed by P. And so this relative Brauer group lie inside the absolute Brauer group, and they're killed by P, they must lie in the P primary part of this absolute Brauer group. But by hypothesis from part 2, this is trivial. So then this means that this relative Brauer group must be trivial, and so this quotient must be trivial, and thus the norm map must be surjective. In other words, every element of L must be a norm in F. Thus we have shown that the P primary part of the absolute Brauer group of L is trivial, implies that the norm map from F star to L star must be surjective.